Have you ever looked up at the night sky and wondered what it would be like to have two suns? It sounds like something straight out of a science fiction movie, doesn't it? A world bathed in perpetual daylight with shadows that dance and twist in strange new ways. But what if this wasn't just a fantasy? What if the biggest planet in our own cosmic neighborhood, the mighty gas giant Jupiter, suddenly decided to ignite? What would happen to us, here on our little blue marble, if Jupiter became a star? This isn't just a simple question. It's a doorway to understanding the very fabric of our solar system and the delicate balance that allows life to exist. Our solar system is a rather orderly place, with one big bright star at the center, our sun. Everything else, from the smallest asteroid to the largest planet, dutifully orbits this single source of light and heat. Jupiter is the king of these planets, a colossal ball of gas so immense that all the other planets could fit inside it. But despite its size, it's just a planet. It reflects the sun's light. It doesn't create its own. Before we can even think about turning Jupiter into a star, we need to ask a very important question. What actually is a star? The defining feature of a star is that it makes its own light and heat through a process called nuclear fusion. Deep in its core, the pressure and temperature are so incredibly high that atoms are smashed together to create new, heavier atoms. This process releases a truly enormous amount of energy. Our sun, for example, is a master of this process. In its core, where temperatures reach a staggering 15 million degrees Celsius, hydrogen atoms are fused together to form helium. Every second, the sun converts about 600 million tons of hydrogen into helium, releasing a torrent of energy that travels through space and eventually reaches Earth, providing the warmth and light that life needs to thrive. So why isn't Jupiter a star? It's certainly big. It's a gas giant, made mostly of hydrogen and helium, the very same ingredients that make up our sun. However, the key difference comes down to one crucial factor: mass. Jupiter is huge by planetary standards, but on a stellar scale, it's a lightweight. It's simply not massive enough to create the crushing pressures and scorching temperatures needed in its core to kickstart nuclear fusion. Jupiter, as we know it, is a magnificent failure in the star-making business. The planet's core is indeed hot, estimated to be around 24,000 degrees Celsius, which is hotter than the surface of the sun. But this heat is leftover warmth from its formation, not from active nuclear fusion. To ignite nuclear fusion of hydrogen, an object needs to have at least 80 times the mass of Jupiter. That's right, 80. You would have to find 79 more Jupiters and somehow mash them all together to create even the tiniest, dimmest star. There is, however, a middle ground between a planet and a star called a brown dwarf. These are often called failed stars because they are more massive than planets, but not quite massive enough to sustain hydrogen fusion like a true star. But for the sake of our amazing thought experiment, let's pretend we have a magical mass-adding machine. We're going to give Jupiter the boost it needs to finally achieve its stellar dreams and see how that changes everything. Let's imagine we've done the impossible. We've gathered up 79 extra Jupiters and have dumped them onto our own Jupiter. As the mass piles on, the pressure and temperature at Jupiter's core skyrocket. Suddenly, a critical point is reached. The core temperature hits 10 million degrees Celsius. At this moment, the laws of physics take over, and nuclear fusion begins. Jupiter has ignited. With a mass of about 80 Jupiters, our new star, let's call it Jupiter Sol, would be a red dwarf. These are the most common types of stars in the galaxy, but they are much smaller, cooler, and dimmer than our sun. From Earth, it wouldn't look like a second sun dominating the sky. Instead, it would appear as an incredibly bright reddish star, far brighter than Venus or the full moon. It would be a constant, unwavering beacon in our sky, visible even during the day. The moment Jupiter becomes a star, the entire structure of our solar system changes forever. We would no longer have a single star system. We would now live in a binary star system, with two suns engaged in a complex gravitational dance. The planets, including Earth, would no longer follow their familiar, stable elliptical paths around the sun. Instead, their orbits would become much more complex and unpredictable, pulled by the gravity of both the Sun and Jupiter Sol. The asteroid belt would face utter devastation. If Jupiter suddenly became 80 times more massive, its gravitational influence would become overwhelmingly dominant. The asteroids would be scattered in all directions. Many would be flung out of the solar system, while a terrifying number would be sent hurtling inwards towards the inner planets, including Earth. This would trigger an era of intense bombardment. For Earth, the arrival of a second sun would be catastrophic. Even though Jupiter's Sol would be a dim red dwarf, it would still be a star, and it would be incredibly close to us. The extra heat pouring onto our planet would be devastating. Scientists have calculated that a red dwarf at Jupiter's distance would raise Earth's average surface temperature well above the boiling point of water. Our planet would become a global steam bath. The oceans would begin to boil away. Earth would be transformed from a vibrant blue world into a dry, searing hot rock, much like modern-day Venus. Life on Earth would face an immediate and absolute extinction event. No organism could survive such a drastic and rapid increase in temperature. The habitable zone would be pushed much farther out into the solar system. Earth would no longer be within this life-sustaining region. It would be firmly in a new death zone, cooked by the combined energy of two suns. Let's step back from the immediate apocalypse and imagine a slightly less terrible scenario. What would daily life look like on a planet with two suns? The familiar cycle of day and night would be completely gone. For long periods, both stars would be in the sky at the same time, creating a bright, overlit day with two sets of shadows. The world would look like a living impressionist painting, with shadows of different colors painting the landscape. This constant daylight would have profound effects on the biology of any life that might exist. The circadian rhythms of plants and animals would be thrown into disarray. Sleep patterns would be impossible to maintain. However, the stability of our climate would be gone forever. As Earth moved in its new wobbly orbit, it would experience wild temperature swings, making it incredibly difficult for any complex life to maintain a foothold. So could Jupiter ever become a star? The simple scientific answer is no. It lacks the mass, and there is no conceivable natural way for it to gain the colossal amount of material required. The laws of physics have decreed that Jupiter will forever remain the king of planets, not a prince among stars. This thought experiment highlights the profound importance of stability. Our solar system works because it is stable. This stability has provided the long, uninterrupted period necessary for life to emerge, evolve, and flourish on Earth. While our solar system has only one star, binary and multi-star systems are incredibly common elsewhere in the galaxy. This means that chaotic, unstable planetary systems might be the norm, and our quiet, orderly single-star system could be the exception. So the next time you look up and see Jupiter as a bright point of light in the night sky, be thankful. It's not a star. And because of that, we are here to wonder about it all.